Hi team, good morning everyone. We'll start in few minutes. Uh, hi friends, let's start. The others might join. So we were talking about inheritance in the last class. I think even we have discussed that what is that inheritance and types of inheritance and single inheritance. Mm, just a minute, friends. Particles. Let me share it. This got stuck. I don't know why for some reason. Can you see it, friends? Please confirm if my screen is visible and my audio is uh, clear to everyone. Please confirm in the chat box. Okay, then let's start. So today let's try to complete inheritance and switch to polymorphism. So till yesterday we had discussed about multi-level inheritance. If you remember, we had discussed about multi-level inheritance. And we have seen few examples for multi-level inheritance. So this is the example we see in the yesterday's session, and we had discussed many things about this one. So here there are a couple of important points we had discussed yesterday. So when we create an object, when we have an inheritance hierarchy, so always it is recommended to create object for subclass. Usually we don't create object for superclasses. I think all of you should be clear with that. Okay, it's not recommended to create object for superclasses, but if needed, we can create. That's what I told. Hope this is clear for all of you. Next one. What else we discuss? Let's move to the next topic. So what is that? Multi-level, multiple. We'll talk about it. Hierarchical inheritance. Next concept. So this is another type of inheritance which Java supports. So what is this hierarchical? Deriving two or more subclasses from a superclass is known as hierarchical inheritance. Understand this definition carefully. Deriving two or more subclasses from a superclass means what? Here, one parent, many children. It's in fact, we can say this is one-to-many relationship. Okay. Single inheritance is one-to-one relationship, right? Multiple inheritance is many-to-one relationship, something like this. If you want to just have a quick understanding. So here, one parent, many children, and parent is common for all children. If it is multi-level, it is level by level. Parent to child, child to sub-child, sub-child to sub-sub-child, something like that. But here it is not like that. All children are at the same level. All subclasses are at same level, and there will be a superclass. This is hierarchical. So what is hierarchical means one parent, many children. Like suppose we have B, C, D. B is inherited from A class, C is inherited from A class, D is inherited from A class. It's not like B comes from C or C comes from D. And also here the relation is between parent and child. Here one child doesn't have any direct relations. So B doesn't have relation to C, C doesn't have relation to D. These are all at sibling level. These are called siblings. So this is a quick idea. We'll see a small example. This is hierarchical. Now what we do is let's rewrite the same program which we created yesterday for multi-level to hierarchical. So let us rewrite this program to hierarchical. I hope you are clear with this multi-level inheritance, right? So after seeing this diagram, you must have clearly understood what is hierarchical. One parent, many children, right? So I have a quick question for you friends. So if we should rewrite this program to hierarchical, parent A is same. Now, what changes we have to make this code to change this to hierarchical inheritance? So any quick answers here, friends? So one thing, B is inherited from A, so no change for this. The second thing, what changes we should see? Here C is inherited from B. This has to be corrected. What should we do now, friends? We should inherit C from A, but not from B. So this is hierarchical. So this is fine. Then in this scenario, so in this approach, one child or one subclass doesn't have any indirect relation with another subclass. Now, earlier in multi-level, a bottom level class can have access to all top level classes. But now C class is a subclass to A and B is a subclass to A. So C cannot access properties of B class and B cannot access properties of C class directly. Indirectly, you can do that is a different scenario. Is this clear for all of you friends? So what shall we do now? Earlier in the previous program, we are accessing this variable C of B class in C class. But now we cannot access this. You can see there is an error because this time C is a subclass of A but not for B. So put your cursor here, friends. So what is this? It is saying C cannot be a result to be a variable. So what should we do, friends? Remove this. So now we are good. This is one change. So one thing. So here we have access to all properties of this parent directly, but not to any subclasses. That is point one. Point two. Now here we have created an object for C class and then we are trying to access addition method of B class. So here can we call addition method of B class on C object? No, this time it is not possible. Why? Because addition is in B class. Now C is a different object and B is a different subclass. C is a different subclass. So one subclass don't have access to another subclass. This is hierarchical, right? All subclasses can access properties from superclass A, but not from one subclass to another subclass. That's why we cannot call this add method of B class in C class or vice versa, or members of C in B class. So remove that add, just call multiplication method from C class. Now again create, now one more thing is in hierarchical inheritance, we should create a separate object for each subclass. Okay, I think this point should be very clear. Now we have created object for C. Now if needed, see in a real time, it's not like we create all objects once after we build a application. It's all depends on necessity. If you create those objects, you create it. Else, whenever it is needed, you create them. That's all, friends. B space B equal to new B, and then call first one B dot set data. Set data always you should call it, because otherwise those variables A and B are not initialized to, are not set with any values, and they are by default set to default values. So make sure you call this set data method, point one. Next one, B dot, you can call add method now. So this is simple idea about hierarchical inheritance. What are the points we have observed here? One parent, many children. You can see here A is a parent. From A, we are inheriting B, and from A, we are inheriting C. And here, all properties of this parent A can be inherited to all subclasses, but these subclasses don't have direct relation with one another in this kind of inheritance. Point two, and here in this approach, we should create a separate object for each subclass whenever required. So now let's run this program. Run as Java application. So it is asking, it is running set data on B object first. So what do you do? Press enter values here. So first one, you can give anything of your choice, 1 and 2. Okay, the sum is 3. Again, it's asking for values. Again, set data method is called on C object. Again, you can enter some more values, 5 and some 8. So you can see the product is 5 8 40, 1 plus 2 is 3. On B object, addition is done. On C object, product is done. Got it, friends? Maybe if you want to see this in a debug mode, maybe you can understand two objects are created here. Right click, debug as. So yeah, Java application, run it. Now you can see debug started. And now you can see here, when we do this debugging step by step, you can observe two objects created, and then two objects are set to this values which we are running from keyboard. Okay, so now let's see. This time you should say step over. When I say step over, by the time this 45th line is executed, you can see B object is created, and then A, B, C, three values exist inside B object. Why A, B, C? A and B are inherited from where? From A class, and C is its own variable of itself. So we have three variables in B object. So what do you do right now? Now again, this is a method call, right? Do step into. Now you have jumped to set data. When you jump to set data, this set data will set this instance variables with some input values which we enter from keyboard, because this is dynamic initialization, right? So now we need step over. Okay, it's asking for input, give some value 1, anything of your choice. Again, step over. Sorry. Again, step over. Step over. Okay, now we have to input a value here. Give something. Again, step over. So when we do this initialization, you can see here, there is your JVM is try to input some values into this variables. You can see A is set to 1 and B is set to 4. Now addition is not happening because still that method is not called. Now we are in set data method because on B object we call set data. Similarly, if we call add method on B object, then addition will be done on this variables, instance variables. So what should I do now? Where am I now? I am at this set data method. So should I say step over or step into step over only? Go to this step over. Now control jumps back to the calling method, that is main. Now it moves to the another method add. Again, this is a method call, right? Now this time we have moved to the next line, and this is a method call says a step into, and then addition is performed. Now what should we call? Should we call step into or step over? These are general statements. Then say step over. By the time you did this addition, you can see C will be initialized with some this you can see resultant variable value. 1 plus 4 is 5. That is assigned to C now. That's happened here. Okay. And then again step over, again step over, again C objects get created. You can see now when you say step over, you can see a new object C is created. Now you can see in the memory, two objects are created. Usually objects exist in a memory area called as a heap. What is that? It exists in a memory area called as a heap, HEAP. If you have any confusion, the spelling of that is a heap, HEAP. Okay, and now you can see two objects got created in memory, in that heap memory. One is B object and C object. And we have three instance variables ABC in B object and three instance variables in C object ABD. Okay, now you can say step into right. Same process. Now I am running it directly because again it goes to this method, step into and try to input values from keyboard. So what you can do is so what you can do simply you can say step into, then this method will try to input values from keyboard. So simply say step into and it asks for values something like 4 and something like 8. I didn't try to step into that now, just moving to the next line because we are very clear like what happens when we step into that method. Now that is done. Now multiplication. What happens to mul method? This time when we step into this, it goes to this mul method, does this product and then assign that result to the D variable and finally print it and come back. That's what happens here. Even now I am saying step over because we are very clear with this debugging method, debugging process. Maybe if you want, you can quickly see it came into this multiplication method, a product is done, step over. By the time you just move from 36th line, you can see multiplication is done, that result is assigned to this resultant variable D here. And then step over control. Now control will return back to caller. And finally, we are in main method now. And main is also about to end the execution. So step over, when you say this execution is completed, control is written back to JVM and then program is disconnected and then terminated. So this is what happens here. And by that time you can see here. So what is that here at the right side window? You have clearly observed two objects created, one for B and one for C for these two subclasses. Understood, friends? This is a quick idea. So this is about multiple, sorry, this is about hierarchical inheritance. So these are three different types of inheritances which is supported in Java, and multiple inheritance is not supported. We'll talk about it quickly now. Okay. So now let us jump to and are you clear till this, friends? Are you clear till this or any confusion? Can I get an S from all of you? Are you clear or any confusion on this? Okay. So if you are clear, then we will jump to the which one? Next one. Right. So what is it now? After understanding this, you can. I believe you are also testing these programs along with me, and please doing that, friends. So next one, move to the. So this is just a quick idea. In hierarchical inheritance, we inherit properties from a superclass to subclass, but it's not possible to inherit properties from subclass to superclass. Not only in hierarchical, in any inheritance. So we inherit properties from superclass to subclass, but not from subclass to subclass. Yeah. This is subclass to subclass and also subclass to superclass. Okay, one because this point is clearly discussed. We can't directly inherit or we can't access members of one subclass to another subclass. Yes, that is what this is. This we discussed. Now, multiple inheritance. What is this? This is opposite to hierarchical. Multiple parents, one subclass. We can say many to one. In a way, we can quickly to understand. We can say this is a many to one relationship. What is it, friends? Many to one relationship, and this is not supported in Java due to a problem called deadly diamond problem. What is it, friends? It is we have a problem called so you can see deriving a subclass from two or more superclasses. This is multiple inheritance. So we can say many to one, many parents, one child class. So if you see here, so this is not supported in Java. Why this is not supported? Let me just add this point. This is not supported in Java due to deadly diamond problem. What is deadly diamond problem? Let me quickly tell you what is it. Let me use paint for that so that it would be better for us. I'm opening paint. Suppose these are multiple parents. We have A class, we have B class. Maybe if you want, you can say C3, C also. Multiple parents. Now this is parent A, parent B, and sorry, let me just make it little parent B and parent C. If you want, you can take more also. Now, what happens now? Assume that so here parent A has a method some set data. Okay. Similarly, parent B also have a similar method set data. Just think about it. And parent C also has a similar method set data. So now what happens here? There is a subclass. What is that? Now we have a subclass inherited from all these parents. So put arrow mark pointing to parents, not to subclass, not to the bottom, but to the. Now we have a subclass some D. Okay, friends. Maybe more than this scenario, we'll do one thing. Let me change this, friends. Sorry. Let's take like this. We have first a parent. Let's take this one, the actual thing which. So we have parent A. Sorry for again correcting this. Now from this A, two subclasses are inherited. Assume that B and C to give you a clear picture about deadly diamond scenario. Now A is so from A, two classes are inherited B and C. Now from these two, one more subclass is inherited, that is D. Now you can see a diamond shape appearing here. Now in here in A class, okay, in A class there is a method. What you can take it as you can take the method name as a set data. Okay, this is the method that is there in this A class parenthesis. Okay, now when you inherit this A class to B and C, the same method of A class is inherited to B and C, right? At this top level, now you know this is a hierarchical inheritance, the bottom, the upper part. In this case, what happens? Same set data is inherited to B class and C class. So now you have a copy of set data here. So one copy of set data in B class. Okay. And one copy of set data. Okay. Here in C class. I hope this is clear, friends. Right. So now you can see this set data of A class is inherited to B and C. Now again, D is inherited from B and C, which is multiple inheritance. This is multiple. The bottom part of this one. This one is a multiple inheritance. So this is actually a hybrid structure. You have a combination of hierarchical and multiple, and indirectly a single. The multi-level is there. Okay, all different varieties of inheritance is involved in this. So this is a hybrid inheritance structure. Okay, now once after this method set data is inherited to B and C, now D is again inherited from B and C. Now here comes the problem with the D class. Now the same set data is present in B class, same set data is present in C class. Now which set data method should be inherited to D class is the ambiguity. Now D has an ambiguity. Should it inherit set data from B class? Should it inherit D class from C class? Is the ambiguity. And you can see a diamond shape here in this example. This ambiguous situation for D class, whether to inherit a method from B or C when these methods are same, is nothing but a deadly diamond problem. So what does this deadly diamond mean? Simply speaking, it is the ambiguous situation of a subclass to inherit which copy of method from its superclasses when that method is same in both in all superclasses. You got it right? This situation we call it as a deadly diamond problem, friends. Understood now? I think you should be very clear. So what's happening here? I am summarizing is you have a method in superclass, supermost class here set data. Okay, right. And now that method is inherited to this B and C classes, subclasses B and C, which were inherited from A. When these two classes inherits, this method set data is inherited to B and C. Now again, you are trying to inherit BC to D class. Now D has this ambiguous issue whether to inherit set data from B class or the same method from C class, which got inherited from A. This ambiguous situation of D, whether to inherit a method from B or C when these methods are same, is nothing but a deadly diamond issue. This situation is called as deadly diamond issue. I hope this is clear for all of you friends. Is this clear? Can you please answer in the chat box if you are clear with this or not? Can you please reply in the chat box, friends, if you are able to understand this? Somebody is asking question, can't we override with our own choice? See here in Java, you don't have any choice here. In Java, we don't have any this thing. This is not supported in Java. Because of this reason, Java is not supporting multiple inheritance directly. Right? It is very clearly stated in the documentation of Java. Multiple inheritance is not supported in Java with classes. It is only supported with interfaces. Is this point clear? Yes, you can override this where in C++ or in other languages there is some kind of alternate approach. In C++, they use a concept called virtual classes to overcome this issue. But in Java people just what they did is they just kept this approach aside because of this deadly diamond issue. I hope this is clear for all of you friends. So this is a quick idea about why Java doesn't support multiple inheritance. Clear now? Right. Now let's move to the next concept. What is it? So we understood multiple inheritance. And the question is, does Java supports multiple inheritance? What's your answer, friends? Can you please answer in the chat box? Java doesn't support, is not supported. I don't know why I put add here in Java. So in due to deadly diamond issue, already we have mentioned this, no issues. Now, hybrid means what, friends? Anyhow, we don't need to discuss these examples. Already we are familiar with inheritance. Hybrid is generally combination of any two inheritances. Now, if you see this example, this is a hybrid inheritance where you combine hierarchical and multiple inheritance. So, when you combine multiple inheritances, two or more inheritances, we call this as hybrid inheritance. Right, friends? So, that's a quick idea about all different types of inheritances in Java. Maybe you can try an example for hybrid inheritance, just combine two inheritances and you can try that. But these three are supported here in Java. The straight away thing is Java supports single inheritance, multi-level and hierarchical. Multiple is not supported due to this deadly diamond issue. Hybrid means combination of any two inheritances. You can also try a small example for that if needed. And if you ask me, can we overcome this multiple inheritance issue in Java means? So here, implementing multiple inheritance with classes is ruled out. We don't have such thing, such support. But what? But we can overcome this with overcome this issue with the interfaces. With the interfaces in Java. I hope this is clear for all of you friends. Maybe if you ask me interface, it's a simple concept. We'll talk quickly. Okay. I hope this is clear for all of you. Are you clear with this, friends, about the deadly diamond issue and then why this is not supported in Java? I didn't confuse you, right? While explaining this, all of you are clear, right? Right. So this is the next move to the next topic. Mm, these are all quick questions. Okay, that's a quick summary, no problem. And these are few important points. Maybe so. What is this deriving a super to subclass is called? Obviously inheritance, right? So inheritance, which inheritance is not supported in Java? A quick question. All of you know this answer, right? So which inheritance is not supported in Java? It doesn't support multiple inheritance. It is not recommended to create object for dash. So we don't create objects for superclasses generally, right? A subclass objects internally consists of it has internally consists of what, friends? It internally consists of properties of superclass and properties of itself. Okay. Next one. How, suppose this is a quick question, maybe important for you. How many classes are there in program in this program, friends? A, B, C, and multi-level inheritance. 4 classes are there. This is another important point, but it's a simple thing only. How many classes are there, friends? 4 classes are there. When you have 4 classes, then 4 dot class files are created. How many dot class files are created, friends? 4 dot class files are created. Means for each class, 1 dot class file, which is bytecode, is created in Java. Suppose if you have n classes in a file, then n dot classes are created for that program. Remember that. Okay. So here, if you see here, dash number of dot class files are created in a program. Again, this is something which we didn't discuss so far. So simple point, remember here 4 classes are there. 4 dot class files are created. Maybe if you want to just observe that, you can quickly check that. What is that? Go to that path. You can see here path is it is in Selenium. Location is this one. D Manoram Shiv. Maybe you can go here. Do one thing. Don't go to the this one. Go to till this path. If you want to know where your file is located, you don't need to take much time. Just go to that file, right click and click on properties. You can see the location of your file where it is stored. If you don't know exact path, okay. So copy this till that folder, tech, and then open this browser and then quickly enter and then now you can start from here. This is the package, right? I just thought to show you yesterday. When we create a package, how that package is created in your local this thing. Okay, so in your location it created like this. Package is nothing but simple, friends. When you say com dot something tech, com is this is actually a super package. I mean outer package and tech is the inner package. So you can see package is nothing but simple folder, simply speaking. Now how it's created in your local area. You can see here under source is created as one folder and com is created as one folder. Tech is created as another folder. You can see here. Okay. And here again, if you see here, this is your this thing project structure. It looks like this. Okay. So com and you can see another package is created like this. And then let me just now you can see here. This is the bin. Under bin, you can find all dot class files created. Understood, friends? Maybe if you ask me where is this dot class files means, your Eclipse will separately create, place this dot class files under bin file, bin location. Now see GNOME tech. Inside GNOME tech for you can see here for multi-level, you can see 4 dot class files created. For A1, 1 dot class, for B1, 1 dot class, for C1, 1 dot class, for multi-level inheritance class, 1 dot class. You can see these are all dot class files. Now we just discussed this point, right? How many dot class files are created for each class in your program means for each class 1 dot class file is created. And in this file we have 4 classes, 4 dot class files are created. That is an important point to be noted. Just have a clear idea, friends. Okay, you can ignore all this, but this is actually a more deeper information which usually you don't usually get in all different classes outside. Okay, so this is a quick idea, friends. So we can declare only one dash. This question maybe you can answer, friends. So what is that? We can declare only one dash class in a file. So what is that one dash class? Can you answer this in the chat box, friends? Maybe you can try this answer. We discussed this point. So generally, right? We can declare only one. What is the answer? Maybe you can give it right. If it is right or wrong, let it be public class. Perfect. Generally, we are declared to declare one public class in a file. Maybe if you declare multiple public classes, maybe if you ask, yes, I will go and declare more public classes, then what? Then nothing happens. We have discussed this point many times in our sessions. What happens then? We should create a separate file for each public class. We should create or we should save that each public class in a separate with a separate file name or with the name of public class name. Is that clear? So next one. If we declare a class as public, then we should save that program with the same name as that public class name. And if you have n public classes, we have to save that program with each public class in a separate file with that name of public class name. That is the rule we should follow in Java, right? We had already discussed this. I'm switching to the next one. So this is in inheritance, we can derive properties from super to subclass, right? Superclass to subclass and vice versa. Vice versa is, do you think this is applicable? Inheritance is applied from, is applicable from superclass to subclass, but not from subclass to superclass. So answer is what? Answer is false. I hope this is clear for all of you friends, right? So, yep. Now next, this is all about what shall we say? Varieties of different types of inheritance and few important questions are questions to have a quick idea. This is friends. Next one, main method. We know of this thing. Let's say skip this, not needed. Now move to the next topic. What shall we say? Abstract. Shall we do abstract now and then after polymorphism? Let's jump to polymorphism, then come back to abstract. I'll just finish it quickly. Now the next topic is polymorphism. Let's have a quick introduction and maybe if possible, let's try to do a couple of programs on this now. So we have two types. Let's try to cover it so that tomorrow we can come back to abstract and complete that and jump to collections. Okay. What is polymorphism? Also, I have a quick idea about interfaces as well before we jump to collections. Okay. So what is polymorphism? I think after the collections, I think we will jump back to Selenium. Probably I'm thinking we will switch back to Selenium in couple of sessions, friends. So we have to start that. So I told right, maybe if needed, I'll do one full-fledged Java program. So maybe for almost for 1.5 to 2 months. You can, if anyone is interested, you can upskill there that Java there. Okay. Now let's get back to this polymorphism. Poly means many. Morphism means forms, right? So this is general meaning of polymorphism. So what is that in Java then? So here this polymorphism is nothing, friends. All again, see now at this level, see already whatever that is needed to understand Java, to implement Java, you are already ready with that, friends. In fact, we covered almost everything in a very detailed approach, even though we spend less time here for Java. Whatever is needed, you are equipped with that. So that you don't need to have doubt that whether I am really done with all concept of Java. Am I good with that? You don't need to doubt it, friends, because whatever that is needed, you are equipped. You are trained on that now. So you can be confident on that. These things what we discuss now. Polymorphism means nothing. Now, see what happens in an AOOP, not only in Java, friends. You go to be Python or C Sharp or any OOP, object-oriented programming. The core area of understanding is object and class and methods. If you really understand these concepts, what is object, what is class, what is method, if you understand these things clearly and how to write a class, how to declare instance variables, how to declare local variables, right? If you understand these things clearly, then this polymorphism, this inheritance, all are nothing but we are just, it's extending to what we have already discussed. Right? It is an enhancement of our fundamentals. That's all, friends. And polymorphism is nothing new. This is a concept of methods. How you define methods in one kind of inheritance, that is a method overloading. And another one, overriding, how you implement methods between superclass and subclass. Here, even though that concept might be a little different thing, but the approach is implemented with methods here. Means if you are really familiar with methods, there is nothing with polymorphism. Simply speaking, I'm just giving a heads up for you. Like, are you really, is there something really a different thing? Means nothing different. Once you are clear with object, class and method scenarios, then these are all very simple concepts, which is built on top of this object, class and method. So now coming back to this discussion, polymorphism means representing same method in many forms. All this is dealing with methods only. Right, and we have two types here. Simply speaking, one is a compile time polymorphism, runtime. Compile time is nothing but is implemented with the method overloading, right? What is compile time polymorphism means binding a method at the time of that method call with a method. You can see here, right? This is the example. Suppose this is the method call and this is the method, right? So at the time of compilation itself, your compiler understands your compiler understands which method should be mapped to which method here. What method we here otherwise? Which method should be mapped to what method in your class? This mapping of method or binding of a method call to a method call to its method is called binding. And if it happens at compile time, it is compile time polymorphism. And generally, this is implemented with the method overloading. Okay, and method binding is what, friends? The process of matching a method call to its appropriate method is known as method binding. Right? Something like a quick example to remember. This is a little fun example. Suppose somebody is marrying, they give those photos, right? So that is that photo. After seeing photo, you go and again watch a boy or a girl. Sorry. So when you watch that boy or girl, again you compare that photo with the real personality. Then you understand whether it is a photographed photo or a real photo. Right, friends? Then you come to a match now. Binding, that your binding happens. Okay, this boy in the photo is real in the again is the real guy, not totally photoshopped. Right? That is binding. So what your mind do now after seeing photo, after seeing real person, it will map, it will check whether both are same or not. Then a binding happens between photo and that real person. Similarly, same thing with methods. Okay, this is just a quick example to remember. You can just maybe if you liked it, just take it. Otherwise, you can ignore it. Now, what is the point here? Method binding is simple between a method call and a method. So what happens? Matching of this method call to a method is nothing but method binding. And generally that might happen at compile time, that might happen at runtime, right? And here method overloading is nothing but a compile time polymorphism. Right. So this is a quick idea. We implement compile time polymorphism using method overload. Okay, that is compile time polymorphism. Runtime is method overriding. We'll talk it there. Let's jump to the overloading now. What is method overloading? It is a kind of polymorphism, compile time polymorphism. What is it, friends? It is a kind of compile time polymorphism. Right. That is what we call method overloading. Now, what is overloading here? Process simple, friends. Same method in multiple forms. It is defining same method with different parameters or in multiple forms. Same method with in multiple forms. Maybe let me simplify this. This might be a little confusing. In multiple forms is known as method overloading. And here we have certain rules we should follow with overloading. But if you see an example, a quick example, you can easily understand what is overloading. Okay, so it doesn't take much time. Hardly it will take just a couple of minutes time for us. So let's see this overloading. So when you do overloading in Java, not only in Java, anywhere, actually not all languages has overloading. Maybe C++ has that, Java has that, and C# has that. I doubt Python supports overloading. It doesn't, there is even if you try to overload, it won't work in Python. Okay, so for now, let's focus here. What are rules of overloading here? First thing, overloading means same method name with the different forms. Method name must be same. Then what must be different? That is what we are talking here. Point one, when you overload method, the name of method must be same. Simply speaking, what is overloading means same method name. You declare it multiple times, but you cannot have same signature. What is it, friends? signature must not be same in all methods. For example, you see this example directly. Let's not waste much time. There is a method name max here with same signature. You can see, right? Method name is same. You can see here. But by looking at signature, observe the signature carefully. Even though you don't have any idea about this overloading, we have max method declared for 2 times. Okay, how many times we have declared max method? 2 times. Now a quick question for all of you. Please answer in the chat box. So when this max method is declared for twice, please answer. Question is, are these methods same or different? Please answer in the chat box, friends. Are these two methods, max methods, are same or different? Answer, please. So what's your answer, friends? Can you comment in the chat box? Are these methods same or different? Please answer, friends. Answer. These are different. Yes. These are different methods. Even though name of method is same, parameter changes here. You can see first method has int parameters. Second parameter has double parameters. That means this is not same. This is a different, these two are different methods. So that those are the rules we should follow here. Rule 1. Here name of the method must be same. Fine. But what should change? Either number of parameters should change. So what is that? Parameters should be different. Means what? How this parameter should be different? Either data type of parameter must change. You can see here in max method, here we have int parameters. Here we have double parameters. There is a change in data type. So this is one thing you should observe. When you overload, either data types of parameters should change or number of parameters should change. I'll show you a quick example so that you get a clear picture about overloading. So this is overloading. So what happens when the name of method must be same, that is for sure. But what should change? Either the data type of parameter should change or number of parameters should change. Maybe you can ask me a question. Manoram, this is not clear for us. Show us an example. Let us go to that then. So let's take a quick example. I'm just naming this class as. Let me show you with example. It's more easier for you to understand with a simple example. Overload. Okay, demo. So now this is put main here and then just leave it. Now what you do now? Class. Some you can take anything of your choice, friends. Some math you take. Okay. Or math 1 you can put because math is a built-in. Sometimes there might be ambiguity. Put math 1. So here you just take public void simple method void add. We are doing addition or sum otherwise. Now I am doing sum of two numbers. But this two numbers, this sum is not just applied only for integers. I want to do sum for different parameters. Some for integer parameters, some for decimal parameters like that. Let me try that. Sum of what is that? Int x, comma, int y. Okay, and then I'm simply saying now I am just taking this as a return type as int. Usually this kind of method should return values. Return x plus y. I'm just directly saying return, friends. You can see here semicolon. This is done. Now I'm creating one more method here. You can see here. Again, one more sub method, friends. See here. Method name is same. Now when I redeclare same method, observe this carefully, friends. We have a compilation error. Why? Because redeclaration is not allowed in Java. Then what is that you should do? Here, my method name must be same, but I am changing something here. See here, friends. Here, I'm changing this to maybe let's put it as double. Okay, let's put this one also as double. Okay, and return type here instead of int, I am changing this to double itself. and you can say return x plus 5. Let the logic might be same. Is this clear, friends? Now the error is removed. If you see, after we changed that data types in the second method, then automatically this error is removed here. You can see here error is removed. Suppose there are two parameters x and y. Maybe if you have a doubt, it's not like you should modify every parameter. You should change all parameters. In this x and y, suppose I can keep double x as double and y can be still int. Here, at least one change you have to do to this another method, overloaded method. You can say these methods are overloaded. Why overloaded means same method name with different forms. This is form 1, this is form 2. And here there is a change in data types, friends. That's all. What we did here, we did a change in data types. That's all. That too, one small change is enough. Here I just modified the data type of X. Now this became totally a different method. So that's what, friends. But generally make sure both are double here. So this is overloading. We are done. Just two methods. If you take example of 2 or 3 or 4 or 10 or 100, it is same. But we don't overload those many methods. Usually at most we overload some 5 or 6 copies. That's all. Or max to that level, max 10. That's all we see. So what's happening with overloading here? With same method, we can declare with different parameters. So the advantage I will tell you now. Why? What is the advantage we have with overloading? If you are asking this question, we'll talk about it. But I hope this should be clear for all of you. What is this overloading? Method name should be same, parameter should be different. That too. Now one difference is here the data either data type should change. This is one scenario. Another scenario either otherwise number of parameters should change. Now I'm overloading one more method instead of what is this overloading two variables. Instead of declaring two parameters, I'm declaring three parameters. Just to show you, okay, and then I can say x plus y plus z. This is another way of overloading a method. So what's happening in third method? Earlier in the first method, I have two integer parameters. In the third method, I have three integer parameters. By looking at this simple program, you can easily understand what's happening here. Number of parameters are changing here. If you have two here in the first method, we have three in the third method, three parameters in the third method. So what is the point here? When you overload a method, friends, what is it? Either number of parameters should change from one method to another method, or data type of parameters should change. Are you following, friends? So when you overload, this is overloading. Same method name with the different parameters or different forms. What is that change we should implement for overloading methods? Either data types of one method should be different from another method, or number of parameters should change from one method to another method. And this approach is nothing. This is the rules we should apply when you overload a method. Is this clear for all of you, friends? I'm just quickly summarizing here. What is overloading means? Same method with different forms. And the rule you have to follow here is either the data type of method should be, what is that rule we should follow here, friends? Either data type should change between one method to another method, or number of parameters should change from one method to another method. These are the rules we should apply when you overload a method in Java, friends. So what should we do right now here in the program? Simply, you can just call some method by passing integer parameters, some 20. Just create an object for math class, math1, and maybe let's apply our learned concepts now. So here, these kind of methods, instead of declaring, I think just spare few minutes, friends. This is very important to know. So if you see, Now let's apply our learnings from previous sessions. These methods are declared as instance methods, but now I recommend just don't declare them as instance friends. Change these methods to static methods. Now this is the time to understand, to apply your learning from previous sessions. So the best thing when you declare these kind of methods is making them as a static methods, public static int sum. Similarly, here also static double sum. Okay, again similarly static int sum, something like this. Are you following, friends? So now you can see we have a overloaded method sum. We have made this method as static. Right? Why we made this as static? Because these are utility logics. Sum is nothing but just doing some addition. For this, declaring instance is not recommended. Why unnecessary? We should create object and then call these methods on that reference. So that is not needed. In this kind of scenarios, declaring this kind of methods as static is the most recommended approach. Why? Because this is a simple utility logic. We are not depending much on any instance variables here. We are just depending on local variables. So these methods are meant for doing some, mathematical operation. When we pass some values, it gives some result. That is enough for us. So what is the best thing here? Better declare this kind of methods as static, friends. Now what do you do? Simply call these methods math1 dot sum of pass integer parameters. Okay. And then maybe what you can do, you can simply, it is asking for semicolon. Int sum result 1 equal to. So now put semicolon here. This is the calling first method. Now second one, double. Okay. Oh, sorry. Double result 2 equal to. Again, while calling method, see friends, see here, observe carefully. Which method you are calling until you pass these parameters, your compiler doesn't know which one you are calling. Now here, when I say 1020, in both cases, it is trying to call some method with int parameters. Now you see, friends, I gave 10.0, 20.0. Now this time, which method is called? Some method with the double parameters. Again, even though method name is same, which method should be called? Which method should be called is decided based on values you pass from here through method call. That's what the advantage with overloading. To the same method, you can pass different values and test your logic. I think this is clear, friends. First, understand this carefully. Later on, I'll show you a real example like how this overloading is really applied in your Java APIs. I'll show that one example. Now, similarly, third one, I think we are almost done. I'm closing this. Just give me a minute. So third one, again, you can take int sum result 3 equal to math1 dot. Okay, sum of. Okay, just pass 3 parameters, 1, 2, 3. Now it's not needed to call all methods in the class. Just for testing, we are doing this, friends. Nothing more than that. Okay, just print these results. System.out.println. First one, this sum is. Okay, first one is we are printing result 1, calling sum with integer parameter. Similarly, declare 2 more prints. I know we are little extending, just please bear with me, friends. Result 2 and result 3, that is enough. Now you can see first one will give us result calling sum with int parameters. Second one calling sum with double parameters. Third one calling sum with more this multiple parameters. Again, some with integer parameters, but with the 3 parameters. Now run this and proceed, and you can see the output. Okay, 30, 30.0 and 6. So this is overloading, but I think I have much more to discuss here. I want to share a few more details on this. So for now, I think you are clear, right? Till this, you understood what is overloading, rules to overload, how to write a simple example, right? And making this kind of method static. And then you can see we didn't create any object here. That is the advantage if you make static. And then we are testing all these methods which we have declared in the math class. Right? This is a quick idea about overloading, friends. Are you clear now? Is this clear till this? Can I get an S from all of you? Yeah, what we do is tomorrow we will recap and I'll share a few more details on this, which will be very useful for you. Okay. And then probably we'll complete polymorphism, interfaces, and abstract keyword tomorrow. Simple examples. Okay. And then switch to collections after that. Thank you, friends. Any questions? You can stay back or else we can connect tomorrow.